So on this class opener, we've already covered functions, f of x, g of x, h of x, function notation, right? So we have three functions up here. And right here I want you to look at the f function, right here I want you to look at the g function, right here the h function. And this is just the notation. Right here f of 0 is really saying to take 0 and plug it into your f function and then work it out. So if I were to do that, I'm first going to rewrite my function, the f of x function. But notice that instead of the x, instead of 2x minus 3, I put 2 parentheses minus 3. That way I could plug in the 0. I'm going to plug it in right there. And 2 times 0 is 0, and 0 minus 3 is negative 3. And that's my answer for f of 0. Okay. For f of 1, again, I'm going to plug it in. And I'm using parentheses instead of the x. And I'm going to plug in the 1 this time, because that's the input right now. I'm putting in the 1. And if I put in the 1, what do I get as an answer?
Negative 1.
Negative 1. Thank you very much. That's my output. And for the last one, f of 2, again, I'm using parentheses instead of x. I'm plugging in, I'm plugging in a 2. And when I plug in that 2, what's my output?
1.
1. Perfect, because 4 minus 3 is 1. And that's it. So we've been doing this. We should understand it. And today we're going to make the connection that the 0 is the input, negative 3 is the output. And a different word for inputs and outputs are x values and y values. So in a sense, we actually have coordinates right here. We have the coordinate 0, negative 3. We have the coordinate 1, negative 1, 2, 1. And all those coordinates could be graphed, and we will be graphing these today. Let's just continue with this exercise. Number 2. We're looking at the g function this time. And once again, I am using parentheses instead of x. And I am plugging in 0. 0 is the input. There it is. And when I work this out, it's really easy to use 0 because 0 times anything, whether it's a fraction or a regular number, is going to be 0. So you have 0 plus 1. Final answer is 1. Okay. How about plugging in 2? Let's rewrite the function with parentheses. And inside the parentheses, let's put the number 2. And it's really easy when you multiply a fraction times the denominator, right? Because 1/2 times 2, if you wanted to, you could put the 2 over a 1, even though it's kind of unnecessary. We have a 2 up on top, a 2 on the bottom. It just cancels out, guys. And what do we have left? We have a 1, or 1 over 1, which is still 1. So what we really have is 1 plus 1, which is the output 2. Okay. Let's try g of 4. Again, let me rewrite it with parentheses. And I'm plugging in a 4. Again, that's the input, so I'm plugging in a 4. And I might as well put it over 1. And when we multiply 1/2 times 4, well, half of 4 is 2. Or if you want to look at a fraction times a fraction and cancel things out, the 4 on top and the 2 on the bottom cancel out. You have a 2 left over. So 2 is your answer. 4 times 1/2 is 2. Bring down the 1, and 2 plus 1 will be 3. So for the input 4, the output is 3. Let's move on to this last one. H of x, and we're plugging in 0. So let me rewrite h of x, but with parentheses instead of x. There it is. And I'm plugging in 0. 0 is the easiest number to plug in to any function because it cancels out whatever you're multiplying it by. So 2/3 times 0, that's just a big 0. And 0 minus 1, well, that'll just give you a negative 1. So for my input of 0, my output is negative 1. My x value of 0, my y value is negative 1. So that's a coordinate, technically 0, negative 1. Let's plug in 3 into the h function. And as you can see, I'm using parentheses again. Let me plug in the 3. My input's 3. And it's as simple as this. 2/3 times 3. When you multiply a fraction by its denominator, it cancels out. So you really have 2 take away 1 left over, which is just 1. So my output is 1. Let's try 6. So there's my function. Let me plug in this 6 right in here. And again, you could put the 6 over a 1, and you could go 6 over 3. 6 on top, 3 on the bottom. That's going to end up giving you a 2 because 6 divided by 3 is 2. And then you have the 2 times 2, which is 4. So let me rewrite this over here, 4. And then don't forget about the minus 1 at the very end. 4 minus 1 is 3. And h of negative 6, you know what, let's not do h of negative 6. Let me ask you this instead. Would it be easy if I tried h of 1? What is 2/3? Let me rewrite it. 2/3 times 1, it ends up being not that nice. Because when you go 2/3 times 1, you end up with 2/3. It's still a fraction. And then the minus 1 over here, you're going to have to change it to a fraction, get a common denominator to be able to subtract them. So it's not as nice as... So what I'm trying to say here is when we have a fraction, it's not as nice as plugging in a 0, because plugging in a 0 will get rid of the fraction. Or plugging in a number that's exactly like the denominator, right? That cancels it out and it gets rid of the fraction. So keep that in mind for today's lesson. Let's move on to today's lesson. Okay, guys, so we have this page of notes that we just handed out. It's 3.1a. We will be graphing a function form equation using an XY table, input-output table. So let's just follow along here. It says, what is the solution to x plus 1 equals 3? What's the answer, guys? What belongs in here? 2, right? Because 2 plus 1 equals 3. The answer is x equals 2, because that's the only number that will fit in the place of x that makes the equation true. 5 doesn't work, 8 doesn't work, because 8 plus 1 is 9, not 3. So there's only one answer here. The only answer is 2. 2 plus 1 is 3, and that's it. Okay? How about x plus y equals 3? When we have two variables, well, there are many answers that work, right? You could say 1, x equals 1 and y equals 2, right? Because 1 plus 2 is 3. Or maybe x equals 3 and y equals 0, because 3 plus 0 is 3, right? Or maybe 4 plus negative 1. Or maybe 5 and negative 2, or 6 and negative 3, and 7 and negative 4, and so on and so on. Or maybe 100 and negative 97, right? Or 1,000 and negative 997, right? How many answers are there? There's an infinite amount of answers. And that's what I explained down here, that there's an infinite amount of answers. 1 and 2, 3 and 0. By the way, instead of writing x equals 2 and y equals 1, let's write it as a coordinate, because it's nicer, it's quicker, it's faster. So we already know that a coordinate is an ordered pair. So your first number is x, your second number is y. So instead of saying, oh, x equals 2 and y equals 1, let's write it as 2 comma 1. That's really saying the same thing, x equals 2, y equals 1. So as we could see on all these, there's an infinite amount of answers. So this is the reason why we graph, to represent the infinite amount of answers that exist to an equation. Notice that this is bold. This is the explanation of why we actually graph. If you have a highlighter, highlight it. Maybe circle it. I don't know, do something to it to make sure that you know that's special right there. Okay, so why do we graph? To represent the infinite amount of answers that exist to an equation. So let's actually take the coordinates that we had, the answers that we had to the equation x plus y equals 3, and let's graph them on an xy plane. So we said 2 plus 1, so 2 comma 1, that's a solution. That's a coordinate. Let's graph the coordinate 2, 1. You're going to go from the origin, 2 on the x, 1 on the y, and you're going to put a dot right there. 2, 1. What else worked? We said 3, 0 also works. 3 plus 0 is 3. So if we go 3 on the x, 0 on the y, it would be a dot right there. So 3, 0 is right there. Or we also said 4 and negative 1. Well, that would be right there. Or how about plugging in 1? 1 plus 2 gives you 3. So 1, 2 is right there. And as you could see, these coordinates, these solutions, they all line up. They all are perfectly linear, right? So how many dots do we actually need to draw a line?
3, 2.
We only need 2, right? 1 right here, 1 right there. But it's a good idea to do 3 just so you could, you know, it's kind of like double checking, or you feel more comfortable about your line that all 3 dots lined up. Okay, so I mean, you could continue, but this is good enough. You could draw your line right through it, and all we do is put arrows at the end of the line, because those arrows represent that it continues forever. So let's go back to this x plus y equals 3. I could even say 100 plus negative 97 equals 3, right? So 100 plus negative 97 equals 3. So I could write that as a coordinate 100, negative 97. And if I did go out from the origin 100 way over here, and then go down negative 97 way down here, it will perfectly line up with the line that we have. Okay, so it will perfectly line up. 100, negative 97, it's way down there somewhere. Okay, so this blue line right here actually represents every single answer that exists to x plus y equals 3. Even decimal answers are represented inside this blue line. Like for example, you could say 1.5 plus 1.5, that'll give you 3. So a coordinate is 1.5, 1.5. So if you did go 1.5 halfway more, and then up 1.5 halfway more, you're going to end up perfectly on that blue line. So this blue line truly does represent every single answer that possibly exists to that equation x plus y equals 3. So we already answered this question. How many points do we need to actually draw a line? Only 2. But we do 3 to feel good. You only need 2, but we do 3 to feel good, to feel a little bit more confident that we did the right line. Okay, let's move on to today's vocab. Function form, very important. Function form is simply getting y by itself on one side of the equal sign. Okay, we need to memorize this, guys. What does function form mean? To solve for y, to isolate y on one side. It simply means to get y by itself. Okay, so let's practice taking these regular equations that have 2 variables and let's rewrite them in function form. So number 1 is not in function form because function form means y by itself. Now you have a plus 2 right here. You don't want this plus 2. So let's get rid of the plus 2. How do you do that? Subtract. So let's subtract 2. 2 take away 2 is 0. What you do to one side, you do to the other side. Could you actually do 3x take away 2? No, you cannot. They're different terms. You can't combine those terms. You're just going to rewrite it. So what do I have left? I have y equals 3x minus 2. And guess what? This is now in function form. Y is by itself. Is function form complicated? Heck no. It's just a question of solving for y, getting y by itself. So let's take a look at number 2. So on number 2, you want to get y by itself. Here's the equal sign. Y is clearly on the left side of the equal sign. You don't want this minus 3x. So you get rid of it by doing the opposite. The opposite of minus 3x is plus 3x. If you have a positive 3x and you subtract 3x, it'll be 0. It'll cancel out. What you do to one side, you do to the other side, plus 3x to maintain the balance of this equal sign on this equation. So what do we have left? We have y equals, you could put 4 plus 3x because you can't really add them. You can't add numbers with variables. But a better answer, because we're going to have to do this on the next section anyway, y equals, write the 3x first, the plus 4 at the very end. I'll explain why later. But for now, the top one is acceptable. Y equals 4 plus 3x. But it's better to write your x term first and your constant second. Okay, so whenever you have an x, write it first. Whenever you have a regular number, write it second. Let's move on to number 3. Is this one in function form? No. Definitely not. It has a 2 right in front of the y. Now, it doesn't say y plus 2. It actually says 2 times y. So if you want to get rid of that multiplication, what do you do? Division. So let's divide by 2. And what you do to one side, you do to the other side. You're going to divide the whole thing by 2. Now, I'll be honest with you. I normally don't divide the whole thing by 2 if I see that this guy's divisible by 2 and this guy's divisible by 2. If that's the case, you might as well divide each one of them by 2. So maybe it's a good idea to not do the whole thing by 2, but let's do the whole side by 2. Let me put divided by 2 here and divided by 2 there. And now we have y equals, this cancels out, x minus 3. And ladies and gentlemen, that is your function form equation. Number 4, so easy you might get confused. Is this one in function form? No. It has y by itself, but it's not a regular y, it's a negative y. You don't want it to be negative, you want it to be positive. So what do? You could multiply everything by -1, right? Or divide everything by -1, but ultimately it's just going to change all the signs. So this becomes positive, this becomes negative, this becomes positive. Y equals -x plus 5. That is your function form equation. Moving on to number 5. Is this one in function form? Yes. No. It has 5y on the right side. Okay, now y is not by itself. Remember, function form is getting y by itself. So you want y by itself. You don't want this 5. And again, this does not say y plus 5. It says 5 times y. So if you want to get rid of the multiplication of 5, you're going to have to do the opposite, which is divide by 5. And what you do to one side, you do to the other side. Now, right here, again, I see 2 terms, and I could do this. I could do the whole thing divided by 5. But if I notice that at least one of them could be divided by 5, I might as well separate the division by 5 and put that division of 5 on all terms. So what I'm going to do is erase this divided by 5 line on the whole thing, and I'm going to do it to each of them. Now, 10 divided by 5 is beautiful, 4 divided by 5 is not beautiful, but so what? I could do the 10 divided by 5. That's why I'm separating it. So what do I really have? I have y equals 10 divided by 5 is 2. There's a minus sign right in front of it. And the 4 over 5, I can't do anything with it, but it does have an x after it. So this is my function form equation, but it's better to have the y on the left side and everything else on the right side. So I'm just going to switch it. Y equals 4/5 x minus 2. That is my function form equation. Moving on to number 6. Is that in function form? Yeah. Is there anything that we could do to make it look a little nicer based on what I've already said?
Flip the 1.
Yeah, change the 1 and the x. Yep, perfect. So it's already in function form, but it'll look a little bit nicer if you have your x first and your number at the very end. Perfect. Do you have to do that? Not really, but it's for the next section when we start doing y equals mx plus b. Anyhow, let's jump to the top of these notes on the right side. Actually, the video is already getting kind of long. What I'm going to do is stop right here and then do another video explaining how to graph a 2-variable equation with these 3 steps here using an input-output table.